Okay, this is a short little lesson on how to state some restrictions for rational expressions. It all comes down to some of the properties of fractions. Fractions, if you have 3 over 0 or 0 over 3. Okay, if you have a 0 in a fraction. Now a 0 on a numerator is okay. 0 divided by 3 is just 0. That is okay. If I have 3 over 0, where 0 is on my denominator, that is an issue. Technically, you're dividing by nothing. How many times does nothing, or extremely very small number, go into 3? It's going to go in infinite amount of times, and that is also known as being undefined, and that is a problem. Okay? So, often on a calculator, that will actually give you an error if you're dividing by 0. So 3 over 0 in a fraction is a problem, whereas 0 divided by 3, that's okay. Now, how does that work into some rational expressions? Well, when you have variables and x's where you don't know what the variable is or what it represents, maybe you need to state a restriction that it cannot be. So x cannot be any value that's going to make your denominator go to 0. So what value is going to make my denominator go to 0? Well, let's take that denominator, 3x, and let's say, well, it's not allowed to equal 0. And I can solve the little equation by dividing both sides by 3. And so that means x cannot equal 0. If x equaled 0, I'd have 3 times 0. And I'd have, which would be 4 over 0, which would be a problem. So this fraction exists, no problem, as long as x is not equal to 0. Let's take another fraction. 5 over x minus 1. Is there an x value that would make my denominator go to 0? So let's take that denominator, x minus 1. It's not allowed to equal 0. The denominator is not allowed to equal 0. If I added 1 to both sides, I'd have x is not allowed to equal positive 1. If x was positive 1, I would have 5 over 1 minus 1, which would be 5 over 0. That's a problem. So this fraction exists as long as x does not equal positive 1. It can be anything else. Take another fraction. Here I have 3 over x plus 1, x minus 3, 2x. So I need to say what restrictions are going to make my denominator go to 0. Well, if it's at 0 at any point here, then the whole thing is 0. Because these are all brackets multiplying together. You multiply anything by 0, the whole thing is 0. So x cannot equal, well, what would make x plus 1 go to 0? Oh, x equaled negative 1. What would make x minus 3 go to 0? Well, if x equaled positive 3, then you'd have 3 subtract 3, which would be 0. Can't have it. And what would make 2x go to 0? Well, when x itself was 0. So I have 3 different restrictions. X cannot equal negative 1, 3, or 0, which would make the whole fraction not exist because the denominator would be 0. Okay, those are my restrictions. If I have 6 over 4ab, now that is 4 times a times b. A couple different variables, but they're all just multiplying together. Now on this, if I had 4 and I put a 0 in for my a and had my b value, then the whole thing would be equal to 0. That's not good. What if I tried when b equals 0? Then I had 4, so the first one was an a equals 0, the second one when b equals 0. 4 times a when b was 0, well then the whole thing would equal 0. And that's also not good. So in this case, a can't be 0 and b cannot be 0. Which is quite common to happen when you have just a monomial, a single term, it's all multiplying together. Those variables in that single term will be not able to be equal to 0. If you have a binomial or a series of binomials, then you can solve each little equation to say, okay, what x values will not equal, will not work with x values are my restrictions. Okay? But if it's just a monomial, often the a and the b or whatever letters there are, they just won't be able to equal 0 themselves because they'll make the whole thing go to 0. Okay? But then you have other numbers that might not work if it's binomials that are on the denominator. Okay, so a short little lesson on restricted fractions. You're just trying to find ways so the denominator cannot equal 0. And you have to state those restrictions. Thank you very much.